Welcome to Brain Vision.
Hi there. So in this problem, we are given this formula for the speed of sound, c, which we can see depends on two variables, the temperature and the depth. Right? And both of these variables also depend on time, clearly, since there are graphs that change with time. So in order to get what we want, namely dc dt, we'll just follow the diagram. I wish you know the chain rule by now. So we will need the partial of c with respect to t times dt dt plus partial of c with respect to d times dd dt. Okay, so what can we get here? Well, for the partials of c, we'll simply use the formula that they gave us, right? So one thing at a time here, but let's first start with partial of c with respect to t. So if we're considering t to be the variable, we're going to get, well, this is just a constant, so we get 4.6 minus, and then 2 times 0.055 t plus 3 times 0.00029. That's oops. Yes, that's a 9. T to the second. And then this last term has no t in it, so its derivative is 0. Okay. And by the way, we're doing all of this 20 minutes into the dive, so t will be 20 minutes. It's always good to check units here, and yes, all the graphs are given in minutes. So we can safely say that t equals 20. Just keep that in mind. Little t. I'm sorry. Yes, little t will equal 20 when we evaluate all of these things. Okay, good. So we're done with partial of c with respect to t. Now for dt dt, the only way to get that is by estimating from the graph. So how quickly is the temperature changing with respect to time? And if we look at the graph, we find 20 on the graph. So find the t value of 20 and look above. Certainly the value of big T looks like it's about 13, just about 13, but we care about dt dt. And I would say if we just look about how this slope is going, it seems to be decreasing by about 1 as we go over by 10. So I would say about negative 1/10. Right, so from the graph, again, I would say this goes down by about 1 degree as we go over by 10 minutes. Again, this is just an estimate, but something close to that is what you should get. And again, also looking at the graph, as long as you were looking at the graph, when little t was 20, it seems like big T is almost 13. We can probably write 13, but I don't know. It's a little less. Why don't we just put in 12.5 as long as we're going to try to get this as close as we can. Okay, and likewise, now we'll plus partial of c with respect to d. This will be a lot easier since none of these terms have d except for the last one. So this will simply be 0.016. And partial of dt, this last term here. So how quickly is d changing with respect to time? Let's look at the graph again. Find 20 on the bottom axis. And let's see, so the value is about 7. So we can pick this off. We can just remind ourselves big D is about 7. But we want d dt. So actually, we don't need the value of big D that didn't show up. So we need dd dt. Certainly positive, it's increasing, and let's see, I'd say it seems to rise 5 as we move over by 10. So I'd say about 1/2. See if that looks right to you. Okay, and the rest is just calculator work. So let's see what we've got. Again, let's make sure we're plugging in 12.5 in for all these t's. Okay, and we'll be getting the following. Let's see, I'm getting negative 0.328. So again, depending what you put in for t, you'll get something slightly different, but that's a decent estimate. And let's get the units correct, as the question says. So we're measuring c. Now c is the speed of sound. So c is already measured in meters per second, and it's a rate. And our unit of time here is also, let's see, minutes actually. So our units of time is minutes. So our rate should be meters per second per minute. And that's how quickly the speed is changing, by this many meters per second per minute. So that's our final answer. Hopefully that helped.